Well, good afternoon, everybody. Thank you all for joining us for our November LEPC meeting. We have a very exciting meeting today because we all want to hear about the winter weather. So we appreciate everybody joining online. Just to let you know, we are recording this meeting so we can post it to our minutes to YouTube as well. For those who couldn't make it, they can watch the presentation at a later date. Jim, would you like to say anything? For everyone in the room, there are microphones in front of you. In order for people to hear you online, if you push the button, it'll turn green, and that way everyone can hear you online. So if you would like to ask a question or speak, please remember to push the button so everyone can hear you. Jim?
Thanks, Daniel. Well, just welcome to everyone in the room. You can tell it's the holiday season, but there are a lot more folks online for what I believe is a pretty important topic, one that we've dealt with in the past, and we have the right person to share this information with us from Wakefield, being Jeff Orrock, a good friend and partner to Team Norfolk. So I'm looking forward to getting this latest information and bouncing it off of our plan, which really describes how we work together in response to these types of events. Being from Ohio originally, it is kind of amusing what a winter storm is here versus what I was used to, but we know that we live in a pretty transient area, and there's a lot of folks who can't drive in this stuff. So we're prepared to lean forward and do what we can in incidents of winter. So with that, Daniel, back to you or to Jeff. Really appreciate you coming out, Jeff.
Thank you, sir. And for those who are just joining us online, I know we may have some newcomers from Gary's group that he invited. My name is Daniel Hudson. I'm one of two Deputy Emergency Management Coordinators for the City of Norfolk's Emergency Management Department. Jim Reddick, who you just heard from, is our Director. He's the Emergency Manager for the city. And Scott Mahone, he's the other Deputy Emergency Manager. He's sitting over to my right here. So we appreciate you being online. For those not familiar with what LEPC is, it's our Local Emergency Planning Commission. This is a group of like-minded individuals, not necessarily with the city, but with their prospective organizations who have emergency management mindsets, who deal with emergency plans, anything like that with their organization. We all get together. We all have information that we share upon. We ask questions. It's just a time for us to gain knowledge from each other and have that community. So if gray skies do occur, we can reach out to each other to tackle whatever comes our way collectively as a team. So we appreciate you being online. If this is your first meeting, welcome. If you would like to join the meeting, please send us an email or give us a phone call, and we will most certainly add you to our monthly meeting that we have here every third Wednesday. We do it as a hybrid meeting, so we have online and in person. So if you can't make it in person, we appreciate you being online. So with that, for those in the room, just for safety, there's an exit right behind you, emergency exit. So if something happens in the lobby, you'll go right out this exit and it'll take you straight out to the parking lot over here. The restrooms, if you go out this door and make an immediate left, the men and women's restroom is right there. And if there's something happening out in the parking lot, we'll take you actually back into the patrol division. So just look for Scott or Jim and we'll start running. So keep up with one of them and we'll get you safe. So well, we appreciate everybody. So we'll go ahead and start with our presentation. But first, I want to give a quick bio of our great friend we have at the National Weather Service. His name's Jeff Orrock. Jeff is the meteorologist in charge of the National Weather Service office in Wakefield and has served with the National Weather Service for 30 years. Jeff graduated from Florida State University in 1994 with a degree in meteorology and began his 28th career with the National Weather Service serving in Pensacola. Jeff then served in the Austin San Antonio office from 1995 to 1998 before returning to the Mid-Atlantic, serving in Morehead City in Raleigh in their National Weather Service office until 2011. In 2011, Jeff returned to Virginia, becoming the meteorologist in charge at Wakefield. Jeff has spent most of his career working with the core partners in emergency management and media, in addition to collaborating with local, state, and federal government agencies. Jeff, you're always willing to help out and be there when we need you. We appreciate your partnership and friendship, and thank you for coming out today to present on, my fingers are crossed, some snow. So I'll turn it over to you, sir.
Appreciate it. Yeah, thank y'all for having me. I love doing the winter presentations because it's like, I can just say, yeah, we really don't know. Good luck. Have a good winter. It is always tricky down here, and I'm not gonna get too much in the meteorology behind the different snow patterns. We can talk about that some if you guys are interested. But I'm gonna kind of get through a little bit of our climatology. You know, why things are so difficult here sometimes when it comes to winter weather, and especially winter weather planning, because you know every year you really never know exactly what's going to happen. It only takes a couple good storms to really cause an issue. What was it? How many years ago was it? We had I guess y'all got about 9 to 12 inches of snow. But the snow wasn't the problem. The problem was, right, it didn't get above freezing. Well, we didn't get above 35 for about five to 6 days. And we went back in to look to see, you know, how often that happens here in Norfolk, that you see more than 4 inches of snow and then it stays below freezing for 4 to 5 days. And it doesn't happen very often. And I think it's like a 1 in 100-year event. So because we were trying to figure that out, because obviously what happens is when the temperature doesn't get above freezing and you get a heavy wet snow, it compacts over time. And as it compacts and also melts, it refreezes underneath. And once it does that, there's not much VDOT can do. I mean, it's the blades float on top of the ice, and it's either use motor graders or chemicals. And chemicals are not an option down here, and motor graders are going to tear the road all to pieces because you're forcing the blades down into the asphalt and scraping it. So it becomes very problematic for free VDOT when we have heavy snow events like that, high water content snow, and it gets that cold. But that's pretty uncommon. You dealt with it quite a bit after that. It's a pretty uncommon event that we get that cold for that long. See if my little, oh, it did not advance up there. So let's see what's going on. Oh, it did. It just took a while. Okay, we'll get used to that. So we're presenting from one laptop and doing it on another. So let's see if it comes back up now. There we go. Yeah, so the main thing to take away from this slide, you know, is when we talk about average snowfall here, it's really pretty tricky. And when we talk about normal snow amounts and departures from normal, it's based on a 30-year running, you know, average. So right now, the average, we're averaging basically 1991 to 2020. And what you see there for Norfolk is that if you take 30 years worth of snow events and you just average it up, it says, okay, the average snowfall in Norfolk, it actually says 6.2 there, is about 6.2 inches. That 8.8 is actually for Richmond. So if we say, what's the average snowfall over 30 years for Norfolk? It comes up as 6.2. The problem is you're averaging some big snow events that are maybe, you know, 12 to 15 inches in with some snow events that are obviously 0. So you're averaging extremes. So if you just look at the actual data and you say, okay, what's the median? What's kind of the median distribution? And you see the snowfall for Norfolk is down to about 3.5 inches, and that's more normal. So if you say, okay, what's more typical in a given year? It's only about 3.5 inches. It's not 6.2. 6.2 is just averaging snow totals, and it's an average of extremes. So that's why you see a big difference there between the average and the median when you start talking about statistics. So, you know, you could say 6.2, but 3.5 is probably a little more realistic. And you see Richmond, the numbers are a little bit closer. You see they're 8.8 and 7.8. And so that's because they're cooler inland. They do see more snow. And so those two numbers are a little bit closer together. So I won't get into that too much, but kind of gives you an idea of some of the variability for snowfall here. So the next slide just kind of gets into the historical aspect of Norfolk, looking at it by decade here on the left, and then over the 30-year period there on the right. So you're seeing even there's a lot of variability by decade as far as how much snow we've seen. In the 2010s, you're about 8.7. You can get 1990s and 2000s. It was a bit lower. So you just see there's a lot of variability is the bottom line for snowfall in our region. Over there on the right is the running 30-year averages. So that's why it looks more kind of straight across. But what you do notice is once you get past, what is that? Once you get past about 1990, you do see the 30-year average snowfalls amounts have decreased in Norfolk. So on the right is the longer climatic trend. And you do see there's been a decrease in the amount of snow in Norfolk over the last, you know, couple periods of climatic records, where on the left, you're seeing more of the decadal variability from every 10 years. So when it comes to seasonal outlooks and what's happened across the area, and I'll just kind of throw some of these numbers up there. I think we'll just leave it. We'll stop it there. Yeah, shoot. That's what I was trying to see what was going to come up. You can kind of see some of the variability there on the right, how much we just get different snow amounts at different years. I mean, and then you see basically the percentiles. So you know, The worst case, about 90 percentile is about 15 inches. So if you had to plan on a worst case probability, that's what that's showing you there. Your worst case scenario in any given winter would be about 15 inches. Absolute worst case would be 35. Good luck with that. But this is based on a probabilistic statistical distribution based on actual past snowfall amounts. That 3.4 inches, that's in the 50th percentile. So that's kind of the middle. You know, what's our typical amount in any given year? About 3.5. But if you go up to the 90th percentile, counting and taking into account 90% of all past snow events in Norfolk, you're about 15 inches. Does that kind of make sense when you're looking at this from a planning perspective? That's kind of what you're looking at there. Hopefully it's not confusing folks too much, but that's kind of showing you the variability. That's a huge variability between 3.5 inches is what would I consider to be our middle of the stream normal, and our 90th percentile is about 15. Our worst case is usually around 15 inches. The absolute worst was about 34.6 in any given winter. So that's taking into account only one event only, basically, is what that's doing, one winter. So as far as, you know, the timing of snow, I kind of like this graphic too, because it really kind of highlights when we do see our bigger events. You see that jump up there. I don't laser pointer probably doesn't work up there, but you see that jump there in the percent probability of basically an inch or more of snow. And you see how much it really jumps up once you get back out past January, especially by the time you get into the second week of January. That probability of seeing an inch of snow is up pretty good. And you notice it stays up there pretty good until we get into early March. And then that probability of an inch falls off pretty good once you get into March. The dark colors there in the bottom, that's 4 inches or more. So when might we see some of the bigger snows? And it's interesting, if you notice, it actually kind of pegs out really the late January, getting into maybe about the midweek of February, right in here. This is kind of our peak for some of our bigger snow events historically. But you do notice that you've had some, 4-inch or more snow events going even into early March. So kind of expect more of our bigger snow events, really more like, I'd say, the second week of January, or getting into later January into February, and then maybe as late as early March. That kind of shows you historically, where our bigger events have happened, with that peak in the 4 inches kind of coming there early February, either side of that first week of February. So I think that's kind of interesting to think it's usually later in the winter that we see our bigger events. There you go. I think I made it for you. So what is the outlook for this winter? This comes from the Climate Prediction Center, which is up in Washington. It's part of the National Weather Service. So they look at things as far as departure from normals and the probability that things will be above or below the normal. So what you're seeing there on the blinking screen in here is basically showing that there's going to be increased probabilities for above normal precipitation here in the southeast and up the mid-Atlantic. So basically meaning that there should be above normal precipitation, whether that's rain or snow. This doesn't really get into that so much. It's just saying, okay, there's going to be above normal precipitation. I kind of throw it out to you guys. Based on that map on the East Coast, what do you think a lot of that precipitation might be tied to, that forecast? Well, it's going to be like, we're coming back to El Nino. What kind of weather systems though? What do you call it? Yeah, nor'easters. Yeah, maybe an increased frequency of coastal storms. Because if you notice, it's got Florida and it's got that basically track coming up through the Carolinas, and it's got up into Southeast Virginia. So it's kind of based on the fact that they're predicting that there should be an increased frequency of storm systems coming out of the Atlantic, out of the Gulf of Mexico, and then maybe tracking up the eastern seaboard. And that's where our nor'easters form, because we've got the Gulf Stream offshore. We get cold air that goes out off the Gulf Stream, off the Carolinas, and those two things combined create a lot of instability. And if you can get some good dips in the jet stream and pull that cold air down and have the upper level energy in the atmosphere combined with the low level energy from the warm ocean, then that's when you can get we call it explosive cyclogenesis, but that's where you get your big storms that generate along the eastern seaboard. So it is somewhat tied to that, and you can kind of see that pattern there where they're kind of showing the Gulf Coast, Florida, and the East Coast being above normal precipitation, because they are expecting an increased frequency in coastal storms. So we'll see how that plays out. I'm just going to go ahead to the next one. So when they talk about temperatures, the confidence is not as great. You notice on the rainfall, they did have the darker greens over us, meaning that there is a better probability of above normal precipitation. Looking at the temperatures, they have us in kind of the lowest category of confidence that we may actually be a little bit above normal temperatures. So we'll see how that goes. This is much more of a crapshoot when it comes to winter weather prediction than it is for precipitation. And I'll talk about why that is in a second. I'd say there's less confidence in temperature outlooks. Usually there's more confidence in precipitation outlooks. And I'll explain that in a second. But we'll see what happens. Sometimes in the pattern that we're in the El Niños, it can be wet, but it can also be a little bit above normal. That being said, having an above normal temperatures throughout the course of the winter, I mean, you're talking about December, January, February. So you could be above normal for that whole time frame, and you could have a really cold 2 to 3 week period in there. And if the moisture hits in that 2 to 3 week period, you get a big snow. You know what I'm saying? So that's where these normals and trying to figure out, are we going to get a storm? They don't always line up. Same thing with like hurricanes, where they say it's going to be maybe a quieter year this year, and there's still a Cat 3 or 4 that hits the U.S. and those people didn't care it was a quiet year. So for us, a little bit with snow, it can be the same thing where the whole winter could be warm, but we could still get a big snowfall. If that cold air is here at the right time, it can be problematic. And if we do see the increased coastal lows, that means there's going to be more opportunities for that moisture to line up with potential cold air. So we'll see what happens. This is just going to be a quick animation showing the sea surface temperatures. It's a little dated, but it kind of gives you the idea. It's still warm out there. So it's just showing you that there's warmer than normal water out in the ocean in the Pacific. And that's really important. That's what defines what's called an El Nino. So the fact that the ocean is warm out there and it's warmer than it should be, that really messes up the weather pattern. Basically creates a lot of shower and thunderstorm activity in the Pacific Ocean, ejects a lot of heat that's out near the surface of the ocean, puts it in the upper levels of the atmosphere out there. And it really does start to modify the weather pattern over the Pacific. And so if you modify the weather pattern over the Pacific Ocean, it's going to affect what happens over the United States. Here we go. Yeah, so I'll just kind of go through all these really quickly. So somebody mentioned La Nina a second ago. La Nina is actually where it's colder than normal. We're in a warmer phase, so we're in the El Nino phase, but it's all called ENSO. It's called the Southern Oscillation. So sometimes a lot of these terms get thrown around. But the El Nino is the warm phase, which we're in right now. La Nina is the colder phase. You hear this talked about a lot in winter weather for us, and then you also hear it talked about a lot in hurricane season, because these do actually play into our weather in the winter and also in the summer. I will say these cycles have a stronger impact on our weather in the winter than they do in the summertime. The reason for that is because both of these, El Nino and La Nina, they actually influence the jet stream. And as the jet stream flows across the U.S., that's what helps create a lot of our big storms. So if this is influencing the jet stream, it's going to influence our weather in the winter and even into early parts of the spring. Typically, for these events to be defined, they have to last at least about 3 to 4 months. And so we're in an El Nino. We've been in an El Nino. They're expecting us to remain in the El Nino here for some time. So anyway, see if that's. I got all these words are popping up. I'll pull them all up. So this kind of just shows you the two different types of weather patterns there on the right. The top is La Nina. The bottom is the typical El Nino. The bottom line is if you look at the upper right in the La Nina, the jet stream is usually a little bit further to the north. It doesn't usually dip quite down as far down in the south. It's typically not as active during a La Nina pattern when the water out in the Pacific is cold. And so usually in those situations, we usually end up with a quieter winter. The bottom screen is what we're in now in an El Nino pattern. The jet stream is usually shifted further south. It's also amplified. It's usually stronger. And so it basically creates more storms. You get more of the dips, more coming right off the southeast U.S. Coast. That's perfect for nor'easters. That's what helps to drive nor'easters, actually. So it kind of starts to pull the ingredients together for an increase in storms across the south. And so that's why they're forecasting above normal precipitation across a lot of the south part of the U.S. and the southeast. So we'll see what happens. This is pretty classic and pretty typical. Again, there's some variability from one event to another, but that's what we typically expect. So that's the El Nino that we talk about. We call it the Southern Oscillation. The other pattern that impacts our weather is going to be called the North Atlantic Oscillation, which I'll talk about that briefly here in a second. That drives our temperatures more than anything else. El Nino usually drives a little bit more precipitation. And this is going to be a little bit busy. But what you're going to see here is basically the difference between El Nino and La Nina in Norfolk. I got to look at my screen here. So on the left is your average temperature. On your right is your seasonal snowfall. And what you notice here during La Nina, right in here, you do notice it's quite a bit warmer. That red line, that's the average temperature in Norfolk during a La Nina phase. And that's what we would typically expect. The jet streams further to the north, it's not as active. So not during La Nina, it's usually warmer. During El Nino, it's really not much of a difference than just a normal winter. In the middle would be a normal winter without either one. And then you see El Nino, maybe it's slightly warmer. Can you see that? I mean, it's barely warmer at all. So the fact that El Nino, they're saying that we could see above normal temperatures this winter, I don't have a lot of confidence in that. You know what I'm saying? That you look at the climate signal, that's kind of why they're saying that, but that's not that much for Norfolk. That's not much difference between, the middle there being Norfolk, being normal right here in the middle, your normal average temperature, and then you see here is what it would be during El Nino. The individual bars that you're seeing up and down, that's basically individual years. So you're seeing how much variability there actually is in the winter temperatures here at Norfolk. It's all over the place. That's what you're seeing there, all those green bars. Looking at snowfall here on the right, the middle would be basically there's nothing going on in the Pacific. It's normal. So this would be your normal here in the middle. El Nino here off to the left. Notice that you're not seeing much of a difference. And La Nina is over to the right. And maybe that red line's just a hair lower. See right there? Maybe it's just a little bit lower. So maybe La Nina, you say, okay, maybe there's a chance that you'll get a little bit less snowfall. But notice the snowfall signal is it's not super strong for Norfolk because we don't get that much snow. Does that make sense? There's so much variability. There's a weak signal there, but you really don't know. Let me go back. And again, the individual blue bars, that's your year-to-year variability in snowfall. So you see a lot of years where there's no bar at all because there was no snow in Norfolk. And you see other years, where there's like maybe 5 inches. You see other ones where there's about maybe 10 to 12. Here's a huge one that's over 40 inches of snow during an El Nino. Obviously, with a record winter there. I can't quite see what year. That's going back into these are actually 5-year periods. Yes, that's 79 to 80. That's 1979 to 1980. What that big spike is right there. Yeah, that's right. So you do see a lot of variability. You do notice you do see you see spikes no matter what. To be honest with you, so it's just that noisy as far as what we see here in Norfolk. So we'll see. We'll see how the year plays out. But I just want to show you guys how little of a difference sometimes there is and how much variability we really get in our winter. The science here, I won't go down the rabbit hole too far, but basically the bottom line is El Nino is kind of helping drive the precipitation. It's increasing the jet stream. It's increasing the flow out of the Gulf of Mexico. It gives us the frequency in coastal storms. Whether the cold air is here or not has a lot to do with what's happening over the North Atlantic and over Greenland and Iceland, believe it or not. So that gets into what's known as the North Atlantic Oscillation. And this is another weather pattern that is variable. It can change on about a 2-week time scale. So it's much more variable than El Nino. El Nino lasts for months. It can even last for over an entire year. The North Atlantic Oscillation has more variability, and it will change on maybe a 1 to 3 week cycle. And what ends up happening is, depending on how the weather pattern is setting up over Greenland or Iceland, that's what causes the jet stream to either kind of be straight across, or is it going to start to zigzag up and down like crazy. And so when we get into a certain pattern, when we get into the negative phase of the North Atlantic Oscillation, basically it causes, see down here, the bottom right-hand picture, this is actually showing you the jet stream. You get very, very strong blocking high pressure out in the middle part of the Atlantic, and it basically that causes the jet stream to do a lot of undulation. There's actually a similar pattern in the Pacific Ocean. We call it the Pacific North American Oscillation, and those are what's actually causing the jet stream either to zigzag or go more straight across, if that makes sense. When we get into these what called blocking highs and things out in the Atlantic, it just, like I said, it causes the jet stream to go up and over it. And then if it has a big ridge develops in the Atlantic, then a big trough develops along the eastern seaboard. And when you have a big trough, like you see that dip, we call these big dips troughs. You hear them called it on TV too. They'll call them troughs. when you get these big dips on the eastern seaboard, it allows that cold air out of Canada to just funnel right down, all the way down, right into our backyard, basically. And then when the jet stream's dipping like this and it's going, over the Gulf Stream, this is basically the recipe to start developing these coastal nor'easters. Cold air, big dip in the jet stream, you get coastal lows coming up the coast. And if they combine with the cold air, then you can start to get into some very, very big snow events. Usually, this is the pattern for most of our big storms. If we're going to have a blizzard here in Norfolk, that's going to be the pattern for it. And we're usually going to be in the negative phase of that North Atlantic oscillation. You can actually track this. If I remember at the end, remind me, I'll show you. You can go to the Climate Prediction Center's website. You can just Google CPC and then Google NAO, or Climate Prediction Center NAO, and you can actually see what it's been doing, and then you can see the prediction going out, I think, for the next almost 2 months of what they think the North Atlantic oscillation, positive or negative. It's showing you positive versus negative. So just remember, negative is cold. If we're going on the negative side of the oscillation, that usually means cold for us. And again, it does have some variability, usually on the time scale of weeks. So it's kind of weird to really think about the type of winter that we see in our backyard is being driven by what's going on in the Pacific Ocean and what's going to be going on in the Atlantic, and especially up towards Greenland and Iceland. And how those impact the actual flow of weather across the U.S., that will result in sometimes what kind of winter we see. When it comes to North Atlantic oscillation, it is pretty cool because we can look out in the future and we say, hey, look, yeah, next week or the week after next, that North Atlantic oscillations forecast to swing sharply negative. And if we know that, we say, okay, well, if we get any moisture, we'll watch out for nor'easters. If we get moisture interacting with that negative NAO, we're going to get snow. We're going to get snow somewhere because we're going to have the cold air in place. So it's kind of neat how these two will kind of play off each other. Just remember, the negative sign minus is cold when we talk about the North Atlantic oscillation. I think I already kind of hit all this stuff. Because there is so much variability with the NAO, you can't really forecast it out more than, I'd say, a couple weeks to a month, where El Nino lasts the whole season. So that's here to stay. The North Atlantic oscillation just has that weekly to even, I'd say, biweekly variation to it. So it's more difficult for us to forecast if it's going to be above normal temperatures or below normal temperatures here in Norfolk, because we are tightly linked to this North Atlantic oscillation and how that plays out through the actual course of the entire winter. So I'll just leave that there. Before I shift gears, any questions about the outlooks or any questions about the season? I don't know. That may work too, to be honest with you. But I'll try to remember to go back because I'm going to go on the web at the end. So I'll try to remember to show you guys those websites from the Climate Prediction Center. It is pretty neat. They're pretty easy to follow, pretty easy to understand, to be honest with you. So we're going to shift gears right into a winter weather event and kind of just, a lot of you guys have seen these before. We're going to kind of talk about the tools, a little bit of how they work. I'm going to talk about some of the resources that I don't have in this presentation that we will be sharing on our websites and in our briefings as well. So I guess, did you forward out the briefings to most of the folks in the room? Yeah, so y'all see some of these graphics as we go through them. So one thing we've been doing for quite some time now with I'd say a lot of success is looking at snow probability. So, there's different ways of trying to predict snow, and when we're talking about models and we're talking about snow predictions, when you start getting within about 72 hours of the snow event, there are literally hundreds of weather models that are running, and you cannot assimilate them all. One person cannot sit there and look at over 100 models and figure out the trends and figure out why. We do have the main models that we use, the GFS, the European. There's a whole host of high resolution models that we use, that we look at. And so we'll quickly kind of glance through maybe as many of about a dozen or 15 models or so. But then there's more beyond that. We call it ensembling that's actually being done. So what ends up happening is, we're looking at the pattern, we're looking at some of the individual model output, but then there's a statistical analysis that's run using basically about 90 to 100 different models. And they're kind of smashed together. And they try to figure, okay, how much snowfall is each model predicting? And takes into account all the different variability, different handling of temperatures and moisture and all that kind of stuff. And so what it starts to do is it starts to give us a distribution, basically. So think of this as that we're running all these models together, running a statistical analysis. And so up here on the y-axis represents the probability of getting a certain amount of snow. And then down here across the bottom would be the snowfall accumulation. So what ends up happening is when you do a statistical analysis that runs on all these models, it gives you a distribution, like a bell curve. And so where you have the peak, where you have the spike, this is where most of the models are clustering. So if this was saying about 6 inches of snow, we would say, okay, most of the models are clustering right around 6 inches of snow. Now our forecast goes into this as well. So this is run the first time with just the model distribution. And then we actually go in and put in our best prediction, and it will actually shift this distribution, either less snow or more snow. I won't get into all that, but we can control the statistical distribution with our own forecast. But anyway, I can explain that more, folks. I don't want to understand that. But this is kind of basically showing you the top of the bell curve. This is the cluster. And so we say, okay, let's say pretend this is 6 inches down here. Let's say most models are predicting 6 inches. If I want to account for as much green as I can, and I want to draw a line, like say right here, and I want to say, I want to take into account 90%. I want to take into account almost all that curve. Say, okay, so say instead of 6 inches, if I want 90%, if I want to take into account 90% of all solutions, that tells me I need to be planning for about 10 to 12 inches of snow. Because there are some models that are predicting higher amounts. Down here on the low end, which we don't use a whole lot, if I only want to take into account, let's say, 10% of the models, I want to go on the very low end, that may only be like an inch. But I mean, that doesn't really help us out much. Usually we're planning on our best guess, which is in the middle right here. This is our best guess. And then worst case. Worst case is sitting right out here somewhere, taking into account 90%. So when you hear us talking about our best guess forecast is 4 to 5 inches of snow. That's where all the data is clustering. Does that make sense? That's kind of our best forecast. That's our most confidence, right here in the middle of this curve. If we say, okay, the worst case scenario, if you want to be worst case, instead of 4 to 5 inches, we could be getting up to 8 inches of snow. And that 8 inches of snow is taking into account 90% of all possible solutions. Does that make sense? It kind of making sense to everybody a little bit? Yeah. I got some examples of what this looks like.
Okay, so you're saying that this represents the total of all the models, and that's where most of them are clustering, is at the top of the bell curve, right?
That's correct.
So you're not looking at specific models, it's just accumulation of all of them.
We do
That's
both.
the best average. Okay.
We do both. I mean, so we are looking at specific models. We're looking at the GFS. We're looking at the European. We're looking at the ensembles of those models, both the GFS and the European. We're looking at a lot of the high-res models, looking at the North American model. So we are actually looking directly at the models, trying to understand some of the variability, how they're handling the cold air, how they're handling the moisture, the timing of the snow, And so when we talk about the GFS and we look at the GFS model, what you're seeing on television when Jeremy or somebody's showing it, or Craig, or Jeff Lawson just left, Tim Panjay's is coming back. And if you're showing it, they show the GFS. They're showing one run of the GFS. There's actually 30 versions of that one model. And so we'll go in and actually look at they look like postage stamps. And we'll actually look at all 30 versions at one time. And we can actually see how all the different 30 versions of the GFS are handling the snow. Some will be forecasting no snow, and some versions of that same model may be forecasting 8. And we're trying to look at the variability. And sometimes we may dive in to figure out why there is some variability in the GFS. Is it because some of the models, have a lot warmer air? Maybe they're tracking the low closer to the coast, so the warmer air is coming in here. Maybe they're lacking the moisture. Maybe they're taking the low further out, and it's pulling some of the models. Some of those members of the GFS are pulling the moisture further out. So we do get in there and try to diagnose why there may be variability within the model. Same thing for the European. The European, I think, it's got 60 members. So we'll get in there and look at some of the variability within the European model. So we really do get under the hood and try to figure that out.
It makes a lot more sense now when you say that you can't analyze all 100 plus models because the level of analysis that you're doing on those for which you're most familiar.
Yeah, and we got some tools. We use some really nice online resources. There's some nice online tools that allow you to diagnose the differences between the different ensembles, like the GFS ensemble and the European ensemble, and trying to figure those out. People talk up the European. The European's been on a struggle bus for some time now. You don't hear people talking up the European as much as they used to. It did not do good in hurricane season, and it's just struggled the last few winters. It's just not calibrated. They're calibrating it for Europe. They're not calibrating it so much for the U.S. So it has been on the struggle bus. Usually it catches up. Usually the GFS is kind of running ahead of it, and the European will come in line. But that there's still some variability there. But yeah, those ensembles with all those individual members combined with the high-res models, that's what goes into this statistical distribution. And once we get within about 72 hours, it's not just the GFS and European anymore. I mean, now there's other high-res models that we're looking at, and the advantages to those is those are able to start to capture, we call it mesoscale features, like snow banding that might set up down here in Norfolk and Virginia Beach, that the GFS and the European, because the grid cells are 13 kilometers, size-wise, you have that versus, let's say, a 5-kilometer grid cell. You're modeling more directly exactly what's happening in the snow squalls with the higher resolution models. So good example with that. If you remember the snow we had a few years ago, we got like 5 or 6 inches down here. I think we were forecasting, I think three or four. We didn't get like 5 or 6. And the high res models latched onto that about the morning before. They started all of a sudden jumping up their snow amounts. And we were trying to quickly figure out why the high res models were jumping up so much more than we call them the global models. And it was locking on to banding that was going to set up right around Virginia Beach and the parts of Chesapeake. Maybe I think it bled into Norfolk a little bit. It's kind of a small band there, I think, of like 5 to 6 inches. And it verified really well. I mean, the band really, it locked in and it stayed right there. And that usually happens somewhere. So that's with our high-res models. So kind of get to the next one. So this is using Sterling's graphics. I should have thrown some of ours in there. But when you go to our website, this is what you'll see. And I'll show you guys what this looks like. You'll basically see our best guess forecast amount. So what is it that we're actually forecasting? Then you'll see the potential for this much. Or actually, I think it says worst case scenario now. And remember, anytime it says worst case scenario or potential for this much, that's that 90 percentile. So you're taking into account 90% of all of the predictions. So it's a good planning tool. If you want to know, hey, worst case, I mean, if I don't want to miss it, how high do I want to go? That's what the worst case scenario or potential for this much means. And so when you go to our website, and I'll show you what it looks like. You have basically the worst case, you have our best guess snowfall amounts. And the other thing you get is actually probabilities of different snow amounts. So you say, okay, what's the chance I'm going to have 2 inches of snow or more? I can click on that graphic, and now this image becomes a probability. And in the example here, I clicked on 4 inches. So what's the chance we're going to see 4 inches or more of snow? And so when I click on that image, the map updates and say, okay, that's the chance I'm going to see 4 inches of snow or more. Now, this is where when we start talking probabilities, you've got to keep that. That's why I showed that bell curve, and that's why it seems like I got a little technical. But when you do look at snow probabilities, you've got to keep in mind what this is representing. Okay, so let's take Winchester, for example, up here, or what's that called? Westminster. Sorry, let me go back. Take Westminster, for example, okay? The probability of 4 inches of snow is 54%. So if somebody sees that and I say there's a 54% chance you're going to get 4 inches of snow. Somebody might interpret that there's a 50-50 chance I'm getting 4 inches. Maybe, maybe not. So all of a sudden they say, well, that's not very much confidence, right? You're telling me there's only a 50-50 chance. But remember that bell curve. So if you're in the 50 percentile, where are you in that bell curve? You're dead center. You are dead center. So 50th percentile on here, you think about that bell curve, you are right in the middle of the distribution. Half of the models are saying more, and half of the models are saying less. So that's where this becomes there has to be a little bit of education with probabilities, because folks can look at that and say, well, over here in Westminster, that's the highest probability on the map. I mean, it's only showing 54%. So yeah, because you're in the middle of that bell curve. And it also tells you 50% of the models are saying more snow than that. You know what I'm saying? So I got to be careful with that. I like the example. If you go down to Warrenton here, it says there's about a 34% chance of probability. 34% probability. Let's get away from chance. 34% probability of snow. I like that 33% because what that's telling you is that a third of the models are saying you're going to get 4 inches of snow. So maybe we're not forecasting 4 inches. Let's say we're forecasting 2. But then you look at that 33%, it's telling you, hey, yeah, a third of the models are saying that we could get 4 inches of snow. That's pretty decent, and I might use that when I'm briefing sometimes, say, okay, well, the worst case is, say like 8 inches. and we're only forecasting, let's say around, let's say we're forecasting around 4. Worst case is 8. So I would say, yeah, your best guess is 4, but I'll say, look, 30% of the models are still saying you could get up to 6. So I say, could if we're wrong, could you, instead of 4, could it go to 6? It could. 30%, about a third of the models are saying that much snow. Does that make sense? How I'm explaining it a little bit? Because if you're going to use the probabilities, you really do have to kind of, and we do this a lot with VDOT, because VDOT uses these things pretty heavily, and so we make sure they understand what's going on. So you get the probabilities of the different snow amounts all the way up to 18 inches of snow.
But it makes perfect sense the way you're explaining it, but it says percent chance, right? So
yeah, and it's really more of a statistical distribution.
Right.
Is the best way to think of it.
That's why I'm just wondering if that could be labeled something else other than.
I'll go on the website now and see what these graphics look like to see if what they have. Yeah, that's a good point, because these are the original ones that came out. So when we'll go live to the website, we'll have to see how they're labeled now.
I mean, because
some of the verbiage has changed.
I remember when you introduced us to this tool, I think it was at the health department, however many years back. It's worked incredibly well since then. We use it all the time. I don't think I ever, and you probably presented it, I just never remember to think that only represents the probability based on the bell curve. I think I was seeing it as the percentage of, but
yeah,
I'll make a note in our plans to remember that.
Yeah, and maybe we can almost develop a reference like this to kind of understand that middle is the 50th, because you can label this like that red line, the 50th. If you the 33% would probably be somewhere right in like maybe right in here. You know what I'm saying?
Yeah.
And the 90th percentile worst case would be somewhere way out here. And, you could actually make one and make a reference if you're looking at this. Yeah. But when you're anywhere 40 to 60%, you're right in here. You know what I'm saying? That 40 to 60 percentile, you're right in that. You're right in the hump of the curve. And I'll show you. We try to make it a little bit easier. I think I should have some examples here. I'll show you guys. We try to make it a little bit easier. So this is going back to a snow case. It should jump ahead. I'm gonna let it catch up. Maybe. There it goes. Just kind of a event from back on January 7th. I can't remember. This is just a few years ago. This kind of just shows you our probabilities going into it once it comes up. The graphics in the upper middle. This was the 50th percentile. So that was our best guess forecast. That was forecasting around about down here in Norfolk. We were right on the line like you guys always are. You were between that 3 to 4 and 4 to 6. That dark blue down here was 4 to 6 inches of snow, and then 3 to 4 was kind of right in Portsmouth. So you were right on the edge of some of the heavier snow. The worst case scenario for you guys at that point was like 9 inches. See how this dark orange got right into Norfolk? So if you took into account the all the different possible models, I want to say, yeah, that's 9 inches of snow right there. So look at the probability down here in the lower corner of getting 6 inches of snow. You were getting up into almost about the 40 to 50th percentile, 40th percentile of getting 6 inches. So you were getting into that sweet spot of the bell curve of getting maybe 6 inches of snow. Probability of 8 inches of snow was much lower. I'm sitting there right around maybe 11%, and the probability of 12 inches of snow down here is almost 0. So not a foot, but you had a probability of getting a little bit of snow there. This was actually issued a little bit later on the afternoon of the 5th. Notice how the probabilities, especially the snow amounts, have kind of moved from Norfolk and started to move inland, and you're getting a big broad band of snow now. So there's a huge broad band of snow. That yellow is 6 to 8 inches, and the dark orange is actually 8 to 11. So we really drove up the snowfall forecast dramatically. Let me go back to the previous day. So this was the previous on the 4th. On the 5th, things changed dramatically, and conversations were starting to change dramatically because we had really increased the snow quite a bit. The difference was, if you look at that forecast right there, that's with a coastal storm staying well offshore. It was going to forecast to stay way offshore. It was going to take the moisture with it. We were still going to see anywhere from maybe upwards to 4 to 6 inches of snow, but it was mainly going to be Southeast Virginia because the storm system was going to stay further out. Worst case at that point was about 8 to 9 inches. Go back to the next day, things have changed dramatically. Much more broad area of snowfall here in the yellow. So this is all basically over about 6 inches of snow with about an 8 to 11 inch swath right down the middle. Worst case, Now, the worst case scenarios has a huge area of about 13 to 14 inches. So this orange that you're seeing here on this far upper right-hand corner, that's 13 to 14 inches of snow. So that's telling you the models have really increased their snow dramatically. A lot more moisture, a lot more cold air. Probability of getting 6 inches, you can see actually 60, 70% in Norfolk. So basically, most of the models are saying you're going to get potentially 6 inches of snow. Probability of 8 inches is also pretty high, about 47% here in the bottom middle. Probability of getting 8 inches. Probability of getting a foot of snow is it's about 16 to 19% down here in Norfolk. So now things have changed quite a bit. Obviously, we'd be highly engaged with you guys. VDOT be talking about maybe some long-term closures. Quite a bit of snow to remove. So that was on the 5th. This was the forecast that was updated on the morning of the 6th using the probabilities. Not a lot of change here in our exact forecast is up here in the top middle. I know that line's kind of splitting it there for you guys, but now we're forecasting a widespread 8 to 12 inches of snow. That's actually what we're forecasting. The worst case has really exploded. Notice all this dark orange, and that dark orange is showing upwards of 14 to 15 inches of snow now. Kind of just carpet bomb the whole state. So what's actually going on here is the models have kind of gone a little crazy on us. And so we're trying to figure out where's the heavy snow really going to fall? Because we know you're not going to get snow. You don't have a heavy snow event that's quite that big. I mean, that's very rare. That's very rare event. So we're trying to figure out a little bit why the models are going crazy. The worst case scenario. I mean, the worst case scenario has 12 to 13 inches in Richmond. I mean, I do remember this event. At this point, they're freaking out. The governor's office is freaking out because now we've been talking about a Southeast Virginia event, and now they're all afraid it's going to hit I-95. I won't say they don't care about us down here, but if they're going to get snow in Richmond, they really get upset about it. So anyway, just figure. I think they think we can just go push it all the ocean down here or something. Sometimes I think they do think that. But this did start a lot more conversations because there was concern about the I-95 corridor in Richmond. So this is where the probabilities helped out. So when I had to talk with the governor's office and some of the folks up there at VDEM, we were telling them, okay, yeah, in Richmond, we're forecasting 4 to 6 inches of snow. Okay, yeah, the worst case is saying 12 to 13 inches. So that's not probably going to happen. So I start looking at the probabilities. So I say, okay, what's the chance you're going to get 6 inches of snow in Richmond in this bottom left? When I looked at the probabilities, I could say, look, yeah, I didn't tell them they were in the 45, 45, 45th percentile, but I said, yeah, you're definitely probably going to see 6 inches of snow. I mean, you're in the sweet spot of the bell curve. I don't tell them that. I just said, yeah, look, you look in the bottom here. Yes, 6 inches is going to be pretty much a given. 8 inches of snow in Richmond. I mean, the probability for 8 inches was about 31%, between 28 to 31%. So I did tell the governor at that point. I said, look, yeah, we're forecasting 4 to 6. I said, could you see 8 in Richmond? Yes. Yes. I think I even said, if I was going to plan, I would probably be thinking 8, because this thing's so violent. It's an explosive system. That's why the forecast has jumped up so much, so quickly. So I said, yeah, I would plan on 8. The probability of a foot in Richmond was like 12%. So I said, are you going to see a foot of snow? And I told him that. So I said, you're almost like a 10%. I said, I would not expect a foot of snow in Richmond. But I told him, yeah, we're forecasting, 4 to 6. I mean, I said, and I think 8's very realistic, and of what could happen there. So I was kind of trying to use the probabilities to explain what was realistic and what wasn't. But you can tell in the upper right-hand corner that when the worst case scenario blows up like that, that tells you some of the models they're going crazy. They're putting out high amounts of snow, and they're kind of putting it all over the place. And so we were trying to figure out how to rein in this upper right hand, because that you don't really want to plan on that, because that's not realistic at that point. I mean, to have 14 inches of snow across that much of the state, that doesn't happen. So this is how you have to be careful with probabilities and figure out what's the best thing to do. That was issued in the morning of the 6th. This was the update for the afternoon. Look at the difference in the upper right-hand corner. Look how the models were going crazy with the worst case. Look how much they pulled it back when they updated that afternoon. But that's just statistical analysis of the model. So they backed it off quite a bit. And then at that point, it had the worst case in Richmond about 10 to 11 inches. And we were still forecasting right around 4 inches of snow. And you really see the probability of 6 inches lighting up. You can really see the rainbow colors here, where you're really expecting that 6 inches of snow. And look right here with the probability of 8 inches or more in the bottom middle one. You can really see it kind of getting on the edge of Norfolk with really high probabilities and kind of really zeroing in on this area southeast of Richmond, getting into Tidewater and parts of Hampton Roads. And even probability of a foot now really starting to light up. Much higher probabilities. In fact, probability of a foot in Smithfield and over towards Newport News is 50%. You've now hit the middle. You've hit the sweet spot for a foot of snow. And this is the afternoon before the snow is going to start falling. So this was our last forecast. This was our last big swing at it before the event actually happened. This is just showing you it's a radar loop. Let's see if it actually plays. See if it's going to play nicely over here. Let me step away because the laptop's going faster. Yeah, it may not. Trying to play it. Give it one more shot. You can kind of see how the snow, this is all snow that's falling here at this point. You kind of see how it kind of comes in, it kind of locks in on Hampton Roads, and you get that second burst right there that comes through. That last little bit that sometimes looks like it's not that much snow, it's actually some pretty good burst of snow. This was all snow, heavy wet snow. This is the wrap right there. When that comes through, that's that wrap around, really cold air on the back side of that low. That can be some pretty decent little snow rates in there. And so it was a pretty good snow event. Coastal low, basically tracking right up all off the coast. It was in the sweet spot for us, basically close enough to bring us the moisture, but far enough away so that we wouldn't get too warm of air. Does that make sense? If the coastal storm's too close to us, it pushes the warm air in from the ocean. So you want to be in that sweet spot. You want the storm to be far enough offshore, where it's going to keep, you'll have the cold air stay over us, but you don't want it to be too far because then it takes the moisture away. And if it's too close, it brings in warm air. So you want to be right in that sweet spot. And we really did get in the sweet spot. It had a lot of heavy snow across the region. This was just kind of a model post analysis showing about 8 to 10 inches of snow almost across parts of Norfolk. We had that foot of snow just to the north on the peninsulas. Pretty good heavy band of snow. Pretty much everything in this shade of blue here. I mean, that's 4 to 6 inches or more. So you're kind of getting in some of the brighter colors right on the edge of Norfolk and there on the edge, and that's 8 to 10 inches of snow. And by the time you pushed up on the peninsulas, it was closer to 8 to even 12 to 13 inches of snow. This post analysis, pretty good wide band of heavy snow. It was it jumped ahead on me. It was a pretty good decent band of snow. In fact, when I look back up to Richmond, Richmond was in that 6 to 8 band. Because I remember thinking that 30th percentile for Richmond verified pretty well. So I remember thinking I was very glad I told the governor 8 inches. I didn't stick to that 4 to 6. I said, yeah, I plan on 8. I said definitely less than a foot. And Richmond did get a pretty good snow event, and this was a pretty wide swath. You don't usually quite see them that wide all the time, with some very high totals right in the middle. And of course, that coastal low went right offshore. And notice down North Carolina, it's green because they got mostly rain. So they were mostly rain down in North Carolina. Once you got over Southside Hampton Roads, we were cold enough to stay all snow. Let's see if I actually have this in here. So this was the example I was talking about from January 2022, where we had the banding. You guys were about 4 to 6, and in parts of Chesapeake and Virginia Beach, we had that band lock in, and they got upwards of almost 8 inches of snow when that snow band locked in. This is actually the probabilities. This is another way of looking at it. So this is a lot of times when it comes up. So to try to make things a little bit easier on you guys, because you can look at the rainbow colors. See if it's going to go. Seeing a different image from y'all, so I'm hoping it's going to. Usually hasn't taken quite this long. Oh, is it clicked online? Okay, so we're delaying in here for some reason. Well, on this computer, it's still showing 2022. There it goes. Okay, wow, that was slow. So what we try to do, you have those rainbow colors on the website. Well, I'll show you guys. When you go there, you'll see those individual probabilities that I've been showing you examples of. You can get to those on the web. When we do a lot of our briefings, when we send out the email briefing, to try to make it a little bit even more understandable, we try to lump the probabilities into 3 categories: low, medium, and high. So basically, the medium threat means that locations will likely experience this much snow. Persons should prepare for impacts from this amount of snow. In addition, some locations may experience accumulations above this amount. So we're taking the exact same probabilities, and we're just recoloring it. That makes sense. So the orange represents the 40 to 60 percentile. And I think the red is like 70 to 100. Okay. And then low, I think, is anything less than 40. Is kind of how we have it. So, and you see the numbers on there, those do represent the percentile. So Norfolk, for 6 inches of snow, was in the 49 percentile. So you were right in the middle of that bell curve, and we highlighted it orange because you're right in the middle of the distribution. So these are the graphics you'll see in our briefings, if that makes sense. And it's to try to, we know if I just put a picture in there and don't explain it of a probability of 4 inches of snow and have that rainbow color, there's a lot of interpretation there. So we've done this ourselves, and they've done this in other parts of the Weather Service to try to help folks make sense of the probabilities. So if you're in the orange area, it tells you right there, locations will likely experience this much snow, period. And you could get more, and if there is any red on the map, it says there is a near certain probability of experiencing this much snow. Persons should prepare for impacts from at least this much snow, and likely we will see higher accumulations above this threshold. So if you're in the red, it's telling you that this is pretty much a slam dunk, and you're probably getting a heck of a lot more. Does that make sense? Because if you have like a 80% chance of getting 6 inches of snow, yeah, I mean, you probably got a 50% chance of getting 8. So it's all probability. So we've tried in our briefings. This is what you'll see. That kind of makes sense to everybody. Same data, same stuff I've been talking about. It's just we're trying to display it differently. Does that make sense, Jim?
It does. It's just so but I mean, I remember writing down the bell curve was really 40 to 60%.
That's right.
Which almost suggests
which is orange.
Right. Yeah. But almost suggests that that's where all the models are going, and I would think that would mean there's a higher percentage than medium that would occur. Or am I missing?
Yeah, it's just how. Yeah, I know what you're saying. So it's how you. That's why we wrote the verbiage over here to try to explain what each category meant. And we didn't just say low, medium, and high by itself.
Right.
That's why for medium we said locations will likely experience this much snow because you are in that bell curve.
Gotcha.
The problem is how do you represent the higher probabilities? You know what I'm saying? So we have to have, there's going to be a category higher than on the bell curve. You know what I'm saying? There's going to be a category that's going to be high. So how do you? I know what you're saying. It can be confusing, and that's why we have all that. We worked on that verbiage quite a bit. We actually took this from some other offices in the Midwest, like in Chicago and places, and we did kind of retool the verbiage over there on the right to try to tell folks exactly what to expect. And so that's why we're briefing this. We'll brief to say, hey, yeah, if you're in the orange area, you're getting 6 inches of snow. We really do think you're going to get it. So that definitely always reference back. This when we send these out in our briefings, this will always be here. This explanation. We won't send those graphics out by themselves. Yeah, to help explain that. Yeah, I know what you're saying though, because it's tough. Anytime even if we have a moderate threat of severe storms, it's like, holy heck, we're about to get killed. So yeah, it's hard to say. Medium for a lot of our things is going to be what you're going to be planning on. Does that make sense? I know what you're saying. In the world of probabilities, it does get confusing. And if medium's not better, if moderate's better, if there are some different suggestions on verbiage, I mean, low, moderate, and high, might be moderate's better than medium. I don't know. Yeah. And it could be, we could change it to low, likely, and definite. But see, that's even tough because people will think, well, if I'm not in the red, I'm not definite, then I'm not going to plan on it. But they should. So it's always open for interpretation, and that's why we try to write in there a little bit to tell folks to definitely be planning on that much snow in the orange areas. But yeah, this is going back. I should have done that. That's going back to the case I showed you earlier. We were forecasting that 4 to 6 inches of snow with the higher amounts in the east. So it did a pretty good job. Even a little early on, the forecast kind of pegging that we were going to have a decent little 6-inch snow event. Potentially over eastern Virginia. Let's see if I had this was the probability of getting into a foot of snow, which I thought was interesting. So it was telling you that this was the worst case. Remember, so you're 10%, 11% of the models are saying you could get 12 inches. I wish I had the 8-inch. I couldn't find the 8-inch. I guess we didn't archive it because the 8-inch was actually showing, like a 1 in 3 probability, especially Norfolk East. I couldn't find it, but you do see here even the 1 foot probability. It's got an 11%, probability there, even with it. So that tells you worst case, yeah, you could get up to 11. 8 inches was getting there was definitely some signal there that we could see up to 8 inches in that event, and it did verify more. I'd say more east Chesapeake into Virginia Beach where we got that some pretty heavy snow banding. So that's I kind of wanted to show the going to shift to the hourly weather graph. I wanted to kind of show what those probabilities will look like in most of our brief. So on the website, they'll look like the rainbow colors that I showed you guys. Send them out in the briefings. They'll look like what I just showed you there with the 3 categories. So if you know that there's all these probabilities for snow, you've looked at it, you're going to want to know the timing. So you say, okay, so how do I get to the timing? And this is where you can go right into the hourly weather graphs on our webpage and just click on Norfolk or click on any location. You can look at the hourly temperature. Let's see if I have, I don't have it. I'll show you how it works. The hourly temperature is going to be here in the top. Wind direction and wind speed is going to be here. So the arrows represent the direction the wind's coming from. So right here where in this middle part where it's kind of grayed out, that's a northwest wind. So wind coming out of the northwest at 13 miles an hour. You can kind of see here where the wind increases, gusting up to almost about 20 to 21 miles an hour here for a while. Again, still northwest. So you look at this, you got the wind blowing northwest. You got temperatures here. They're going to be like right around with maybe mid 30s. If you look down further, you got your precipitation type. So green represents rain. Red would represent thunder, so there's no thunderstorms. Here's your blue for snowfall. You got your purple for freezing rain and the orange for sleet. And so you can look for here hour by hour and say that the event's going to start out as a low chance of rain, probably eventually becoming a little bit of rain. The rain's going to mix, with freezing rain here for a few hours, if you guys can see that. And then the freezing rain is going to go basically start to mix with sleet. And that's going to last until about maybe noon. And then we're going to go over to, looks like mostly all sleet. And eventually we're going to change over to snow by the time we get somewhere right around 6 o'clock. Now, this is our best guess. So, I mean, if it starts snowing, I mean, we actually get emails from folks saying, you said it's going to start snowing at 6. It started snowing at 4:30. Okay. It's like we were close, yeah. So it's, be careful. We are usually pretty close. I mean, could this be off by an hour or so? Yeah. Timing of cold air, how this stuff surges in, trying to get it down to the nearest hour can be tough, but you're kind of getting an idea of the trends and what's going on. And then of course you can kind of go ahead and out in the time in the future and figure out what's the temperature going to be at for the next couple of days. The blue line, which I'll go to the website here and show you in a second how this works. This blue line here where it says sky cover, right there. The blue line does have some importance. Most of the time I tell people don't worry about sky cover, but in snowfall it actually is important. Can y'all see that dark blue line right there? Mm-hmm. How it crashes. So the dark blue line is how much cloud cover you have. So obviously if the blue line is up here to 100%, that means you have total cloud cover. If that blue line down here for the day after the snowfall is down around 25%, that means like 25% of the sky will have clouds. So you're going to have a good bit of sun. So that's actually kind of nice to know sometimes, are you going to get some good sunshine after the snow falls, or is it going to be cloudy? If you can get sun coming through and you can start to get exposed pavement, things can start to improve pretty quickly. And then you can actually go in to see, then what's the temperatures tonight going to be? If we're going to have sunshine tomorrow and the temperature is going to be 38, what's the temperature going to be the next morning? And if we still have clear skies and that temperature is getting down to 27, 25, all that water is going to refreeze. It's going to freeze into ice and you're going to have slick roads again. So there's a lot you can start to infer from this hourly weather graph, and I'll show you guys how to use that. The main thing is, just there's a lot of sources out there for weather information. The TV stations, they'll typically try to stay a little bit closer to us. I feel for them a little bit because I know they've only got 3.5-4 minutes to kind of explain a very complex situation that really does have a lot of probability in it. And then it's hard for them to explain the probability. So I saw it last year too, or year before. That's where sometimes you'll see the forecast come out and they give us, I know what they're trying to do. They show the models, they'll show like the GFS and they'll show the Euro, then they'll show their local graph or something like that. And so you've actually seen like 3 or 4 different potential models, and then they put up a forecast and it'll be like 2 to 5 inches. And then you're like, oh, really? It's like, is it 2 or 5? That's a huge range. Our best guess forecast usually is not going to be more than a few inches, like, 1 to 2, 2 to 3. We can do 3 to 5. We can do 4 to 6. We could do 4 to 7. And then as you get higher amounts, then the ranges get bigger. So it could be end up being 8 to 12. Then 12 to 16. So we do try to narrow. Our best guess, we try to narrow that down as much as we can, and then we use the probabilities to communicate, which direction it might go and where. But it's hard. I know it's hard for the folks on TV to do that. Definitely watch out for social media sources. I mean, it's the Wild West out there. There's a lot of great weather information out there. There's a lot of great information out there. I mean, anybody can go in and look at all the probabilities on the European. They can go look at all the snow probabilities on the GFS. They can look at our snow probabilities. And people can start to create whatever forecasting graphics they want. And nowadays with computers and just the online model resources that are out there and the graphics that just the websites make that are just, just the model websites, it makes some impressive, very pretty graphics. And you can make a forecast off of anything in any way you want and make it look really, really nice. And that's why you're seeing all these little social media things popping up. Some of the folks are probably pretty good, and some of the folks, it's a lot of folks have to get the worst case or get folks excited. So our job is just to be as accurate as possible and to convey, our concerns with what we're seeing with the forecast and what we're seeing with the model trends, and try to communicate the what ifs as well as our best guess. So we really do try to be as accurate as possible. We're not in to try to keep people, keep people tuned into us or clicking on our website or our social media site. So, and the TV stations aren't either. They really do a good job trying to communicate as best they can, what's going to happen. So just be careful, especially when you get out there on social media. It does start to become the Wild West very, very, very quickly. And there's nothing we can do about it. We've had folks reach out to us and say, hey, can't you do something about this guy or this person's? And some of the TV folks have been upset about with them. And it's like, it's they can do whatever they want. I mean, they also have no responsibility, for it either. It's just people follow them or they don't. So yeah, we can't, if folks come on our social media and start trying to share their forecasts, we've shut that down. That has actually happened where people have tried to push their own forecasts on our social media sites, and we delete them. We blocked a few folks from being able to post, comment on us. So it happens. It's out there. So it's I'm not saying don't look at it. It's fun, but just kind of make sure you're kind of checking back with us and see where we're putting in there. Yeah. So I'm gonna try. How much time do we have? I don't go over too much.
Keep going, sir.
Okay.
One thing I really liked this year from the National Hurricane Center was their Facebook Live briefs concerning storms, the storm that was coming up or that they were focusing on. They jump on their Facebook Live pretty much daily and do a 2-3 minute brief of what that storm was predicted to go or where it was going. What I really liked about it was the authority. People could really go to them for the trusted information versus those onesies and twosies, weather people who are online putting out that worst case scenario. So that's just something maybe for y'all, if there's something coming. People really want that trusted information. The graphics are great, but when you have that authority in front of the camera for 2 or 3 minutes talking about it, bringing it down to the level of this is what we're seeing, it really could yield a lot of great results for you.
Yeah, we're talking about it may be more YouTube versus Facebook Live for us. I did Facebook Live a couple of times on my personal account, which I was on a slippery slope because I was briefing weather off my personal account for Facebook Live. And I had a lot of people tune in because I told them I was going to do it. I got to look to see what our policy is on Facebook Live now, because it keeps going back and forth of it's a good avenue. What we're going to start doing is this December 4th is on Monday. You know how we send out our weekly briefings on Monday and Thursday? So we're going to start out with Mondays at a certain time. There's going to be a standing link, and you click on that, and it's going to be us briefing with the week's weather live. And then it'll allow you guys in a webinar to actually type in questions too.
That's great.
So you'll be able to maybe send a couple of questions in, and we're going to do that every Monday to kind of get down this road of what you're talking about. And then we're going to see if we can start to do it maybe a little more frequently.
That's fantastic. Thank you.
Yeah, the big dilemma we run into with the winter storm we're really getting it. A lot of it becomes time because, you know, on a typical event, we're doing anywhere from 12 to 15 conference calls a day. And that's in addition to the forecasters, you know, actually doing the forecast. And there's collaboration of how much snowfall to forecast where the watches and warnings need to be. So yeah, I will say our resources really get thinned out fast. And the more we've done, the more we work with people, the more conference calls we have. So we, you know, sometimes your own worst enemy. You know, because it used to be, it was like 6 or 8. Now in a full-blown winter storm, like I briefed there, that big one, easily 15 conference calls, you know, between all the different VDOT divisions, you guys, the port authority is going to be involved in this. So we'll be briefing the port as well, at least twice a day. You'll have the governor's office engaged at that point, maybe even legislatures. And then sometimes the state starts spinning up these PIO calls. So they want their PIO folks to call in from across the state and media. So, yeah, it is very effective. And so I do want to do more of that Facebook Live, more directly to the public interaction. Yeah, that's, I know what you're saying, because it definitely helps.
We're loving it. I mean, they're all over jumping on it, not non-governmental, just private citizens seeking that information. So that's great. Yeah, and they did it on YouTube as well. They posted it on there.
Mm-hmm. So when we do that, when we start these webinars, they're going to be webinars. There'll be a standing link. You guys will be able to click on it, come in, well, to kind of brief the weather for the week. And then while we're doing that, we're going to be recording it. And so the idea is that when we're done with that session, I'll be able to take that recording and ship it right up to YouTube and then send it back out. Say if you missed the morning briefing, you know, here it is. So it'll be in addition to that PowerPoint, that deck, the slide deck we send out. It'll actually be somebody talking about the, you know, kind of going through it versus just.
Great. Are you going to do that in the Slack channels, or is that going to be something separate?
It'll be something separate. We'll actually share. We can share the YouTube link via Slack once we post it, and we can actually even put the link in there for folks to join, so we can advertise it. But we're going to use what's called GoToWebinar because it can hold so many people. It can hold over 1,000 or so folks, so people can just come in and join.
That's great.
Yeah. Plus, allows us to mute everybody. There's a lot of controls in there, so you can make it so that when everybody joins, they're automatically muted. You know, so to kind of make it a little. But it does make, like, if you wanted to ask me a question and you're in there, you'd actually have to go in there and type your question in and just send it to me, and then it'll pop up on my screen and I can see what your question is. So we're going to start that hopefully December 4th, Jim. Kind of these, we're going to see if we can pull it off. So just a weekly standing briefing. Everybody can join in at a set time. It's going to be like around 10:30-ish. I got to double check what we decided on because we were trying to make it fit into making sure we've got everything we need. We actually have the briefing together, and then we're able to do it. I don't want to do it too late. I think our morning briefings at 9:30, so I think we had settled on 10:30, 10 or 10:30. Does that sound good to you guys on Monday? Yeah, Mondays. What's that? Oh, I don't know. Well, we do have a few things. In fact, a lot of the winter stuff I showed you guys is actually on our winter. We actually, that whether you want to know, that's actually, we're trying to create these little series called Whether You Want to Know or Not. So that's our little, we're trying to start these little educational series. So back to our website real quick.
Jeff, before you get off your topic, are you going to include the private sector folks that are involved in business continuity, disaster recovery in these groups? Or do we need to tell you who those groups are?
Yeah, you probably got to tell me who the groups are. That's you get a private sector, it gets us on a very slippery slope where we can start to get into trouble.
Well, not everybody, but at least the ones that have business continuity and disaster recovery as part of their job description.
Yeah. I think if we can do that and make sure folks are on a distribution, make sure you guys know, because it'll be a standing meeting all the time.
Okay.
As soon as we advertise it and folks know that's there, they'll be able to just click on the link.
Let you know who these groups are.
Yeah, and I'll send you the link so you'll be able to.
All right, that's good. Thank you, sir.
Yeah, no problem. I know what you're asking. Yep. Yeah, they do. It's about 11:30. Mm-hmm. Yeah, so they're doing the same thing. I think it's a standing. I think they have folks join live. I know they send out a recording. I think they're doing it live too. He might actually know if they're doing it live or not. We were going to try to do it live and record it while we're doing it live. And I think Raleigh might be doing the same thing. Yeah. So that's what we're going to try to do. We might be able to do it more than twice a week. I mean, more than once a week. We're going to start with Mondays, then we might have to start doing it on Thursdays too. We'll see. I got to get folks used to doing it first. It's a different mindset, and trying to get everybody involved and trying to do this. You got to have more than just one or two people doing it. Yeah, that's for sure. So back on the website, to get to the snowfall forecast is easy. Weather.gov/Wakefield, but to get you to our website, just scroll down the page and just look for the snowflake. Once it scrolls down here, you'll see the snowflake icon, and you just click on the snowflake icon, and then when you click on the snowflake, it'll pull up the winter weather page. But actually, you know what? Let me go back. There's a lag online too. I've already called it up. It'll call up the winter weather page, which basically looks like this right here. Yeah, so that came up fast. So you see the expected snowfall right there in the middle. So that's our best guess. The point forecast will just basically say what's the exact amount. Usually you want it to say range. That'll give you, instead of saying like 3.2 inches, it'll say like 3 to 4. I don't like points, but look at the range. It'll give you the range of snowfall. The high end amount, again, that's what we say a 1 in 10 chance. So it's taking into account 90% of all possible solutions. That's what you're seeing here. And what was the word you were looking for earlier, Jim? That was confusing, you said? I think that was it right there. So it does still say chance. Yeah, so this is where you see the probabilities of, like, if I want to see the probability of seeing 4 inches or more of snow, 6 inches, you can click on them and make them large, or you can mouse over them. And as you mouse over them, they'll update in the image down below. So this is where you can kind of get in here and say, okay, what's the probabilities of seeing the different amounts of snow? And I do like it. We made the images black now. I like the black background better because it's going to make the colors stand out a little bit better. So here's one thing we don't like that we were forced to do. If you notice, they changed it from a rainbow scale to this blue graduated scale. Yeah, I'm not a big fan of that. That was a national change. So it's still the same probabilities, but see how they now have it in this blue graduated thing? Yeah, that's fun to look at. Because sometimes it's hard to tell, am I in the light blue? Am I in the next to light blue? I was not. We gave feedback on this when they did it. Kind of wish they had not done that. And we've had some folks, reach out to us and say, well, white should mean snow. White is 0, but white, I assume snow. It's like, well, no, white is 0, but thanks. So I don't know. But yeah, they went into this, I think, actually last year. We just didn't have any snow last year. They changed to this scale, and we gave feedback, but we still have this scale. So again, that's why we put the low, medium, and high in our briefings, partially because of that scale too. You guys being in Norfolk, this next part's not super exciting, but because you're kind of small. But in some of the counties, people can go in here, especially some of the bigger counties. I'll use Chesapeake, for example. They can click on Chesapeake, and they can actually look at the different snow probabilities of different locations across Chesapeake. I mean, Norfolk's kind of, you can do it. I mean, you'll have ocean view, and we can see what it looks like for Norfolk. You guys aren't, it's really good for especially big counties. Let's see what actually Norfolk looks like. Where are we at here? There we go. Yeah, so you got Naval Air Station, Oceana, Willoughby. So you can see the different probabilities. You probably won't see much variability in the probabilities from one location to another, because Norfolk is fairly small, fairly small areas there. But you can do that. Look at the individual probabilities at each location, as well as just looking at it. Well, look. So where that is nice, if you're on the map and you're like, man, I can't really tell what these numbers are, and I want to see it on one thing, you can scroll down to the bottom. That does make it useful. Select Norfolk, and then you can actually see, what I'm saying? You can actually see the table of probabilities. What I'm saying? That may be a better way to, if you don't want to have to look at it on all the maps, that does actually have some utility there to look at the actual probabilities. And again, the expected snowfall right here in the middle, right here, this right here, you're going to have the expected snowfall, your high end amount, and then again, these are all your probabilities of different accumulations over here off to the right. So that's kind of neat, kind of nice. A lot of people don't scroll down that far; they stop at the map. So just remember, go down underneath the map, and you can get that little more graduated table there, where you can see the probabilities a little bit easier. There are a lot of other tools on here. Only thing I'll mention, the day 3 through 7 forecast. So this will be an outlook going out to beyond. So we're only forecasting snow, and this isn't populating right now because we're doing this a new way, and we're going to start pushing the graphics. Thought we were supposed to start pushing the graphics yesterday, so I'll find out what's going on. But if we forecast snow through the first 72 hours, the first 3 days. And if you want to see what the risk of snow might be, 4 days from now, 5 days from now, 6 days from now, 7 days from now, that's where you go. You're going to have graphics. And it is based on probabilities of snowfall amounts. We're actually redoing how we did. We're doing it a little bit differently this year than we did it last year. It's actually going to be even more usable. So, even if there's a probability in the future of, let's say, a really decent probability you're going to have 1 to 2 inches, it's going to highlight yellow and say, okay, we'll say limited impact, but it's going to say there could be 1 to 2 inches of snow at day 7. And so, that's on the winter page, same page as with the maps I showed you. You just have that day 3 through 7 winter tab that I clicked on. Now it's hard for you guys to see, but anyway, that day 3 through 7 tab right there, that will give you the outlook for each day. What else is on here? Oh, timing graphics, where it says onset timing graphics. So that comes out of our forecast system based on how we're creating the forecast. And so you'll have a graphic for telling you when the snow is going to start and another graphic saying when the snow is going to end. So it'll be the same. You can go to hourly weather graph. If you go here, this will just be a map of the entire area, if that makes sense. It may look weird. It may show 5 to 7 a.m., Virginia Beach, and you come into maybe Norfolk area, it's got 7 to 9 a.m. and then it's going to be bands of time is what it's going to be, not snow amounts, but bands of time. And the same thing with when the snowfall is going to end. So it has its beginning map with time and an ending map with time. So that can be a neat resource. We'll probably share that some more this year. The other graphics which are not on here, which we'll actually share with you guys, we'll make sure that they look right. We do 6 hourly snowfall rates. So within a 6 hour, over a 6 hour block, let's say from 6 a.m. to noon, it's a map graphic, and it says, okay, what's going to be the highest snowfall rate during that time? And so we'll have those online as well, basically showing you snowfall rates in 6 hour blocks. Say, okay, when is the heaviest snowfall expected to occur? The highest rates. It's also on the hourly graph, yeah, and we're going to have it on a map graphic as well. So it's like, especially for folks looking kind of more of a regional scale, like VDOT and things like that. They like to see the snow intensities and on kind of a map where they can see it across the entire region. What's the snow intensity going to be? The other thing it's been experimental the last couple of years. Last year we didn't get a chance to test it. We have another graphic that's called snow composition. And I think that's done on a 3 or 6 hour time scale. And it basically represents dry versus wet snow. So it is color coded red versus blue. So red would be dry snow, and I think blue is wet snow. So, and you can actually see and click on those graphics over time, and it'll show you, maybe it starts out as a wet snow and ends as a dry snow. And so, it's huge. It's done better in some events than others because you're really getting into now relying on a lot of modeling, because that's not something we're creating on our own. We're relying on a lot of these probabilities and things to generate those. And it has a lot to do with the thermal structure. You're really getting into the weeds of how snowfall, is made up. Because you guys know a lot of times when we're dealing with snowfall here, you have the big flakes, you have the small flakes, you have different, what we call composition as the bottom line of it. And so that can relate directly into how much snow you get. And it can also relate to the fact that, you can be able to go out with a snow blower and just blow the snow off. Or is this stuff, you try to shovel the shovel and it's as heavy as all heck, because it's got so much water content in it. Ironically, you get more snow in a dry snow than you do wet. Wet snow is more compact. You can take the same amount of liquid and you could have a wet snow and only get 3 inches. You could have a dry snow and you could double it because dry snow is fluffy, takes up more space, and so it gets deeper. And so even when we're trying to forecast snow events, we do actually think about dry versus wet snow. So those are the 2 types of graphics that aren't on here that we will have available this season. The snow rate graphic as well as the snow composition graphic. And I got to remember exactly where we're going to put those and share those. But those are fairly new in the last couple of years. We just haven't had a chance to really share them with you guys. Last thing I'll mention really quick, the hourly weather graph. Does everybody know how to get to the hourly weather graph? Yeah, basically just interact with the map. Click on it, click on Norfolk. It may take a second to come up. This will give you your forecast at a glance. The bottom line is you have this interactive map here on the right. And so this is where you can kind of move around if you want. If there's a winter storm warning in effect, it'll show up on here in big bold red. You'll be able to read the forecast. If you keep on scrolling down, you'll see this big hourly weather graph right here. It's like it updated. Just click on it. The only reason I like to show it to folks is that you can clean it up. It's very busy when you first call it up. So you can turn off what you don't want. So if you don't want to see dew point, you don't want to see, let's say, humidity, precipitation potential is a chance of rain or snow. So you may want that. Sky cover we talked about. Wind you're going to want. If there's no thunder, obviously you can turn that off. You may want everything else here and then resubmit it. And then it basically just kind of cleans up the charts, the graphs a little bit. So you can kind of see what's going on there. So now you see the temperature, the blue is the wind chill at the top, your wind direction and wind speed, your sky cover, right in here. So you can see cloudy tonight, going to be sunny by the time we get into tomorrow. And then there's no precipitation forecast. That's why it's all blank down here. The brown line for precipitation is at 0. The other trick to this, let's say we're forecasting snow maybe Friday going into Saturday. You can go change your start time and say, look, I want my forecast here to start, let's say Friday at 4 a.m. and go in through the weekend. So I change it to Friday 4 a.m., hit submit, and now the left-hand side is Friday 4 a.m. and now it runs through the weekend. In fact, here you can actually see when the cold front's coming through. So this is actually getting us into the grand illumination. So good news is, looks like the rain comes through Friday afternoon into Friday evening. Not much rain though, and then we dry out. But then it gets pretty windy. It's going to be probably a northwest wind sustained about probably about 16 to 17 miles an hour, maybe gusts up to 25. And you see the temperature starts to kind of come down pretty good. Wind chill by 9 p.m. should be in the low 40s. So it'll be seasonally cool. Definitely going to be breezy around the buildings. Because you get a breeze like that around those buildings. You guys know how that is. It's coming right down. It's coming right off the river. You know what I'm saying? It's coming right off the river. So yeah. So the main thing is to be prepared for that wind. It's not dangerous by any means, but it's going to be breezy. It's going to be whipping around down there. Mm-hmm. Yeah, so when we update this thing, I mean, it's even throughout the snow event, this thing we'll be sitting here updating this stuff. And we use it when we watch it. If all of a sudden I'm going to do a briefing or we're coming in the morning and we click on this and it's like, something doesn't look right. I mean, we bring it up real quick, say something's not quite right with the hourly graph, or we need to look at the temperatures. Yeah. So there's a lot of great resources. It's just go to Wakefield website, click on the snow icon, or just interact with the map, and you'll be able to get to probably most of what you need. I did mention CPC. So if you want to see these outlooks, I think it's kind of news feed there. If you just Google Climate Prediction Center, you'll be able. It'll come up. Yeah, you're gonna see all the protests. Yeah, you can send it. And once you get there, you'll see links to the ENSO. It's called ENSO or El Nino, and you'll see links to North Atlantic Oscillation. I guess I was going to show you guys. I'm not going to try to click on it, but once it comes up, I was going to show you what it looked like. And maybe it's not going to come up. But when you go to the Climate Prediction Center's website, you'll actually see the outlooks for this week, next week, the 1 month outlook. You'll see the winter outlook I just shared with you. But then on the left-hand side, you'll see links right here. It says El Nino, La Nina. You'll see NAO. So you'll see it'll be real obvious. It's going to be on the left-hand side if it ever comes up. On the left-hand side of the page, you'll see NAO and you'll see El Nino, La Nina. So it's pretty straightforward. But yeah, this is definitely, there you go. Well, kind of. But this is the Climate Prediction Center's website. So all the outlooks there in the middle. And then on the left-hand side, it hasn't populated yet. But on the left-hand side, the blue bar, it hasn't shown up yet. And that's where you'll see all the El Ninos. There it is. See it says El Nino at the top? And then you see, there's a lot of stuff here. You can kill yourself. See where it says, y'all see where it says NAO right there? So there's a lot of other oscillations. You could really get into climate if you want to. But right where it says NAO, do y'all see that? Yeah. You click on that and that'll take you to the North Atlantic Oscillation predictions. And you can play around. It's a neat site if you're interested in some of the longer term outlooks and what's going on from the Climate Prediction Center. So that sounds a lot, but that's all I had. This was any other questions.
That was fantastic. We really appreciate it. If there's any questions online, you can go ahead and type it into the chat. We'll make sure that Jeff answers those questions. Any questions in the room by chance? Wow, Jeff, you did a fantastic
No, I
job.
appreciate it. Trying to stop sharing. Anyway,
As always, we appreciate you. Are you sticking around for a moment?
yeah, I can stick
Okay,
around for a little
great.
while. Trying to
Because we
stop
have
sharing.
something for you at the end, but we
Okay.
wanted to make sure we get to our next presenter really quickly. So we also have to follow up on this. We have our next presentation is from Maurice Gunn, who's going to talk about the snow removal process for the city of Norfolk. So I'll do a quick bio, then I'll turn it over to him. So I said, I actually liked it, to be honest. I thought that was fantastic. That's a good suggestion. That'll be in the plan next year. So appreciate you, sir. Thank you. Thank you. So Maurice Gunn hails from Raleigh, North Carolina, and currently calls Chapel Hill his home. With a remarkable 22-year career in the United States Marine Corps as an engineer officer, he has proudly served in the areas of base maintenance and foreign affairs. Maurice's dedication to public service extends beyond his military service, encompassing 21 years and invaluable contributions to various North Carolina municipal governments, including Chapel Hill, Durham, Morrisville, as well as cities like Charleston, South Carolina, Mooresville, North Carolina, and Burlington, North Carolina. Notably, he has played a pivotal role in the city of Norfolk streets and bridges, further highlighting his commitment to enhancing the communities he has been a part of. Maurice Gunn's extensive experience and unwavering commitment to civic duty have left a lasting impact on the regions he serves. So we appreciate you, sir. Thank you so much. In order for everyone to hear you online, you have to have this mic with you when it's turned on green. So if you do walk around, we just ask that you hold it so everyone can hear it.
Thank you.
Happy birthday.
Yeah. Thank you, everybody. Appreciate it. That was a great weather. Information, because based on that information is what we're gonna do. Because we'll work generally 3 days out. We'll work 3 days out from notification, and then we'll start gearing up our people and letting people know that we have a potential event coming into play. Today, I'm gonna cover roughly 3 areas: the pre-event, density, and some of our priorities. And I'll start with, this is I guess you could say it becomes a chaotic event. How do we know, and how does the public know that everything is okay and we get back to norm? One of the key indicators, school. When school is open, people go, okay, we're all right. We're getting ready to move on and get back to our norm. So, because it is a shift in paradigm, we will we'll do everything we can to make sure that those yellow buses get back on the road. That's a good indicator for our public to know that that everything is back to normal. All right. Every year, stormwater. I used to be in stormwater. Streets Division will conduct a rodeo. And the rodeo consists of 3 phases. The first phase is we'll bring half our staff in, and we'll have a safety training, talk about the equipment, talk about the public. We'll talk about the general safety of the public and what we do when we're out there with that big equipment. Prime example, Virginia Beach Boulevard, coming down to Brambles. That's a hill. There's a light at the bottom. Well, how do we sand and salt that? We have to do it backwards. Got to go backwards up the hill, so that way our tires, have bite as we put product down. Okay, so we're trying to prepare. We prepare that. We go through key areas where we'll make sure we put sand and salt, or just sand. Sometimes it's just salt. All depends on what it is, and again, it depends on the weather and what the weather's doing. Is the wind blowing? Is it high moisture content? Is there an accumulation or an expected accumulation? The second phase is we go to Harbor Park. And I don't know if you've seen it this year. We go out to Harbor Park and we'll set up our cones and barricades. And what it is, we'll create an obstacle course for our drivers. Some of these drivers are new drivers. We just recently hired. They never pushed snow in their life. And so now they're getting ready to go out there and do this. Well, they're accustomed to driving a dump truck, but what they're not accustomed to having is all that weight or that blade that sits 10 feet wide and your truck's only 8. You know, how do you move down the road with it? And what we do is we turn the blades at an angle to meet the 8-foot restriction. But the wide of the turn is different as well. You have to almost be in the other lane to make a right turn, for instance. Just so, otherwise you'll be in the left lane on the other side as you make a turn. So these are training phases that we take our folks through. And besides the weight of the truck with the sand and salt spreaders that are on there. And we do load them up. Sir? Yes, we do it in October. Yeah, we do that in October. And we just recently completed that training. We're getting ready to do a makeup training session, and that's next week, I believe. I believe it is next week. We're doing it for drivers that come from other departments. They might come from Park and Rec, they may come from Stormwater, or they may come from one of other division or departments. And then the third phase of it is we actually have them, we don't put the plows on or the spreaders, but what we'll do is we'll put them out in their trucks and drive their actual routes. Get familiar with your routes. Is there construction on the route? Is there an obstacle on the route that you have to be aware of? And if so, let the supervisor know. And then before any snow event, we'll go back to our notes and we'll go see if that obstacle is still there. And if it is, we'll mark it so that we're there. If there is a great accumulation, we know that there's something there, we have to be careful. Or we'll let the drivers know, hey, we just milled this road, we haven't paved it yet. So guess what? All the manhole covers are up about 1.5 to 2 inches. So when you go through, make sure you raise your blade up, maybe 3 inches, and we'll get off what we can, but we can't go down for the simple fact that we'll take, not only will we damage a blade, we'll also rip out the manhole cover. So now we created work. All right. The next thing is I want to make mention is the density list. Density is nothing more than what we have to do work with. We use snow plows, spreaders. We have brine trucks, backhoes, and motor graders. And roughly, it's about 55 pieces of equipment that we use to accomplish what we're being tasked with. And it's any combination thereof. The materials currently on hand, we've got 10,300 gallons of brine, staged, ready to go. And what we do is we'll pump it, circulate it, load up the tanks, and we'll start hitting the key areas. Some of the key areas that we'll be hitting will be bridges, slopes, underpasses, things of that nature. And we have those all identified. They're all identified on routes. And when we do send them out, generally we'll do it during low traffic. So we may send crews out at night while folks are sleeping, so we can get a good coating out there and let it dry. And that's when it works. It dries. Then when the precip comes, then that's when it starts to break down. Makes it slushy or makes it look like it's just rain. And you can look off to the side and you'll say, wow, the grass has ice on it. And all of a sudden you see the road and you say, but the road's clear. You know, it's the heat. It works with heat and the friction of the vehicles along with the salt, sand, salt, brine solution. We have roughly 700 tons of salt in our bins and 300 tons of sand is what we have now. And then what we do is we have certain locations. We got one over here on Sewell's Point, where we have a storage tank there, our storage area there, and that storage area has a sand and salt mix. And I'm not a fan of sand and salt mix, and that's been a real popular mix around here. I'm a salt person. Put the salt down, make it go away. You know, sand and salt. Sand has a tendency, if you do have you don't have enough salt down there, but you have enough to cause the sand to melt its way into the ice. Doesn't really do anything for you. But the salt does. Salt works. So it's expensive, a little more expensive, but it works. But there is a time when you do need to use the sand and salt mix because you need an abrasive, something to grab. Mainly like your overpasses, I like to do salt, then come back with a light coat of sand on top of it. All right, personnel. We roughly use, we have about 60 people that we'll have for our snow and ice event. And we create 2 12-hour shifts, roughly about 30 people on each one. Neil will manage one of the shifts. I have a new person coming on board, Mr. Wilder, be with us starting Monday. And I sent him, I emailed him a copy of the snow plan so he can be reviewing. I did say thanks. My bad. I did say thanks. I did say thanks. Yes, I did. I did send him an email and with an attachment of the snow plan for him to review. And he'll have a shift as well. And I generally, I'll be on both shifts. I'll move myself between the 2 shifts. I'll commute. We have an FOC, which is the Field Operations Center. And then we'll work with the EOC. We do receive information from the EOC. Hey, we got a concern here. Police department had an accident over here. Can you send a truck over here? Yes. And then, so we'll have that happening in the FOC. And also the day shift and the night shift, they're receiving the weather information, and when they do the handoff, not only are they handing off personnel and equipment, but they're also handing off what the potential weather is going to be for the evening. Because I tell you, 2 o'clock in the morning, you're not moving anything. There's no snow and ice to move. You can do a lot of brining to help break it up for the day shift. All right, moving along. And there are other departments that do get involved in the snow and ice plan. We're generally in the streets, but we also work with the Park and Rec. They have their facilities, libraries, places like that. They have to get open. Fire department, police department. They have crews that they'll send out to those facilities. And then not only that, we have our primary routes. And our primary routes is, we have a primary route and we have our secondary routes. The primary route are those arterial routes that go through the city from one end to the other. East, west, north, south. Then we have our secondaries, and they're the ones that's off the arterial routes that do connect the arterials, but they also encompass fire department, police department, and hospitals. All right. In that, I'm just for a minute, I'm just going to say a little bit about our primaries. A lot of people, you get people that come from, they accuse us, we're from the South. We don't get, we don't get the New York snow, the Connecticut snow, the Massachusetts snow. We don't get that. And one of the big things that we're faced with that they are not really faced with, and that is black ice. We deal with that. And anybody in the mid-Atlantic area, Virginia, North Carolina, mainly, we're very good at it, I think, because we know how to deal with the black ice, and we know what to do, what kind of product do we need to get down there, and a lot of it is mainly the salt and the brine. We do a lot of brining. Brining's cheap, so we put a lot of brine down. And then we'll follow up with salt if we know if there's going to be a certain amount of accumulation coming in. So it does work for us. And as far as plowing, we don't have the big 4-foot plows. Our plows are 2 foot. And basically we push it off to the windrow and we let it melt in the gutter line. Try to make at least one pass through. That's our priority. And then as we go through the different shifts, we make it wider. We're doing. A lot of people, well, aren't you going to come down our subdivision? No, unfortunately, no. Not.
I remember looking through primary routes and the secondary. Just to do 3 passes. I mean, just providing that type of content. It was eye-opening. Yeah. You're able to get to you because we're doing something. Just one swipe doesn't do it.
Well, we have a lot of 2 lanes and we're trying to get curb to curb on both sides in both directions. So it takes a while for us to get there. Now, if we have a grand accumulation, I'm sure we will go back. We're going to review some things and we're going to have to start getting into subdivisions so people can get out. And then we generally probably look at contracting. And we have clauses within our contract that tell contractors, hey, if you're working for us and this happens, you help us. So we put that in the game plan as well. So we're, so we try to tackle it from every angle. And we try and make sure that we're being very informative to the customer, to the system. We do get the phone calls. When are you coming? Police department, they'll call about accidents and we'll figure out what route that's on and we'll tell that route person to get over there and help them out, put a little product down so they can get that squared away and move it on. And so basically what I mentioned was, what do we do before we start? We got some prep that we do. Make sure our equipment's up, get it through maintenance. Make sure personnel are being trained. Make sure we have product staged, ready to go when needed, and make sure our guys understand our routes and identify our routes. The only route the newest route that we created started last year, and we wrote a plan just for it by itself, and that's the CFI. That's the continuous flow intersection, military highway, because there's a lot of lights and changing lanes. And so we hired a contractor in the last snow event that we had. We had a contractor come in that came from the Fredericksburg area, and we handed them the plan and told them, you work this plan. And not only that, we've never done it, so it was good. We gave it to them. We said, see what it works, and we asked them to tweak it, in which they did a pretty good job tweaking it up for us. So it allowed us to kind of make some adjustments as well. And the big plan was go all the way through, stay off of Princess Anne and all them on the sides and Norview and all that. You don't need that. Go through first and then come back. And then on your way back, you start peeling yourself off. So we didn't think of it like that. We were trying to clean intersections, they were saying, no, just clean all the way through. So it worked out for us. And we had an inspector assigned to that specifically just to take notes. So we did that. So. All right. And I do have a copy of the map. If you want to take a look at it afterwards to see what a primary route looks like, secondary route, we do have those for you to review and take a look at it if you wish.
And we do have a copy of those in our plans, which are online.
Mm-hmm.
View those, they can
look
at the plan.
Yes. And we review that every year. And after each snow event, we make notes. And what happened on this event, we make our notes, and if there are any changes. And that's how we improve our plan, is by making sure we keep copious notes of the event, talk about it afterwards, make changes if we need to. If not, we'll keep it going to the next one.
If you got it trained. Whenever we have a winter, that confidence office
Well, there's quite a few military people in there, and one of the things I guess we bring to the table is management by chaos. We get used to it. We know about it, and we know it well. And the goal is make it go away. We try to do that as much as possible with the safety of everybody in mind. So we got a good team, good team of folks that help out.
Well, thank you so much, sir. We appreciate you coming out. Thank you very much. If you wouldn't mind, we can head in the middle. We got a little something for you.
Oh,
Yep. It's coming. It's coming. So we have a certificate of appreciation, sir, for you, and it just says grateful recognition and genuine appreciation of your dedicated participation as a guest speaker at the Norfolk Local Emergency Planning Committee. Thank you for sharing your invaluable insights, experiences, and expertise to our Team Norfolk LEPC partners. Our goal of building critical relationships, facilitate cross-sector collaboration, and information sharing continues to thrive because of your efforts. So we want to say thank you so much, and there's a form there. If I can get a picture really quickly of y'all two. One, two, three. All right, thank you.
right.
And Jeff, if you wouldn't mind coming up really quickly. True. Right. Did you hear the certificate, sir? Okay, fantastic. Here we
Or
go.
fire weather issues coming.
I'll get a picture of y'all as well. Thank you. One, two, three. All right. Thank you so much. Well, both presenters, we really appreciate your time coming out and sharing your expertise and your experiences with us. Most certainly, it's very valuable, especially when we're talking about relaying information to our community based upon what the National Weather Service is telling us. So you guys rely on the information that we're receiving, and Jim does a fantastic job being very transparent of giving the information that we're receiving. So we look forward to that continued partnership with y'all throughout this season. And hopefully it will be a great winter for all of us. So
Great. Yeah, no, right.
I had my fingers crossed for snow, but then he said nor'easter. So I was like, that's not great news. But again, thank you both so much for coming out. So yeah, so now we're moving into the kind of the open forum. I know it's a little bit difficult with people online and in the room, but this is an opportunity for you to share any type of events that are occurring, that are coming up for your organizations, any questions that you may have, concerns that you want to present to the group. Just a time of collaboration, just a time of being able to communicate with each other, and then just making sure if everybody's okay, if they need anything. We'll start first over in the EOC. Hopefully everybody is ready for the Grand Illumination Parade this weekend. Saturday night, downtown Norfolk. Yes. Yeah. It's going to be chilly and windy, but it's going to be a fantastic night to celebrate the holiday season with Santa coming in. No, that's not going to be me, although they did ask. So we're really excited about the parade coming in on Saturday night. Weather's looking great. And then also on Saturday morning, we're going to have the 5K race in the mile run in downtown Norfolk. And then on Sunday morning is the half-mile run in the 10K all the way down Hampton Boulevard. So anywhere from 5 a.m. to noon on Saturday in downtown Norfolk, and then on Sunday from 5 a.m. to noon, expect some road closures. So it's going to be an exciting weekend for us. We are setting up our unified command. That's how we'll operate this weekend. So everything will be great, and we're looking forward to it. Jim, anything from your side, sir?
Only to stick with the winter theme, the fact that, well, so when Jeff was showing the amounts of snow that we've received in the past, if we were ever to think about getting a federal declaration, any type of assistance to reimburse the expenditures and everything else, we have to be within 10% of record snowfall. And that's hard to get. I mean, and it's intentionally. I mean, FEMA doesn't really look at snow events as disasters. So it's a pretty high threshold for us ever to be considered for that. And we'll communicate that whenever we're working through those things. We'll share it amongst Team Norfolk and the media as well, just to set realistic expectations. But it's a pretty high bar and very rare. The only other thing is, and I'm not still sure how we would do it, but if we experienced on 64 or 264 what happened on I-95 or in Atlanta back in 2014, how we can get folks whatever help they might need. Because, I mean, mentioning black ice, I mean, we have partnerships, obviously with the Guard, with the Tidewater or Four-Wheeler Drive Association, but ice is ice. I mean, and every vehicle is vulnerable to that. So just knowing that my oldest daughter, who has special needs, cognitive delays, all kinds of behaviors, who is diapered, I can't imagine her being stuck on the highway and not getting the services that she needs. And so what we might be able to do to help meet those needs of our residents or visitors, if we are ever in that situation of hours on the highway. I don't know the answer to that, but that's certainly something I'm trying to think of in the back of my mind. If you come up with the ideas, let me know, because right now I'm thinking either the local Guard, who might be able to assist, because that decision has to go to Richmond and back, or snowmobile leasing facilities or something. I just don't know what that is. So.
And we did just that. He wanted to exercise 64 in that section being shut down from a snow event. And we created the scenario, and we talked about some of the things we know that have happened in the past from Raleigh and up in. I mean, one of the big issues you're going to run into is folks abandoning cars.
Yeah.
And the problem then becomes is who has the authority to move those cars. And that a lot of folks, that conversation doesn't happen, and people are kind of like looking at each other like, can VDOT just plow these things off the road? Does state police have to be out here? Because that's the first thing that starts happening, especially here, because people can walk to resources. So folks will just give up and they'll just leave their car. And then and it may just be where the road just backed up because maybe there's ice on the bridge and folks are stuck and they get to the point where I've had enough. And they just go walk to a hotel or business and their car's there. So it's just the food for thought, is especially with this group. It would be a neat exercise to do somewhere and to talking. How do you deal with it?
I'm glad you said. Thank you, Maurice.
Just to share with you that I was in Raleigh when that same thing.
Oh, okay.
Yeah, same thing happened, and the governor. Yeah, it was I-40, I-85 shut down all the way from Durham through Raleigh to the other side. All the municipalities that had jurisdiction along those, and I had two ramps. I was in Mooresville at the time. Yeah. And so I was responsible for clearing off the ramps, which normally I'm not.
Sure. Right.
So it's a DOT event. So I was asked to clean off all the ramps that were associated with it. And I had to pick up the closest parking lot to the ramp and clear them so they can start pushing cars or taking cars to those locations. And they had wreckers, picking them up, and they had, this is here and there, and I guess somebody was noting tag numbers and all that.
That's crazy.
But it was the ice.
Yeah. But I mean, to your point, it may be a state-owned road. It's in our community. So we assume that type of responsibility. I'm assuming. I'll reach out to Newport News, see if we can get an after-action report from that. And Maurice, if you have access to one, I'd love to see that as well. I'm glad I brought it up because you guys definitely gave some food for thought, and we'll add a little bit more to the draft and probably come back to this group so we can kind of talk it through and do a tabletop on it. That's all I have for now. I think there'll be more either next month or the month after with what we're really looking to accomplish in 2024. So
I appreciate it. Thank you, sir. Thank you very much. All right. Anyone online, if you have anything, please put your hand up or type it into the chat, and Scott will go ahead and answer you or go ahead and call upon you so you can go ahead and speak. But anyone in the room have any? Yes, sir. Go ahead.
You could possibly, other cities send me a list of the road closures so that I can send it out to our contractors so that we're not in your way. We shut down, we get it safe, so that we're not in your all's way.
I'll send it to you today, sir.
And
Yes,
I'll
sir.
send it out. Thank you.
Oh, certainly. Okay. Anybody else in the room? Here we go.
Past snowstorms we've had, you guys have done a great job with special requests, because I've called your office and I've asked for private areas to be plowed, like the Red Cross on Hamilton Avenue, because they were delivering blood to the hospital, but they couldn't get the blood out of that parking lot and just going around, less than a mile away to the hospital. So you guys came and cleared that. And some of the nursing homes that we do have a request for, that they can't get the private Bobcats come in there. If we call you, you guys send it out there, not publicly telling anybody out, because we'd get too many requests, but you guys do a great job with those private and services for us. And thank you.
Well, we tend to, we'll always have a couple of the impact team because of that very same, so it's not, we do have everything dedicated out. Pick up truck, plow. We'll just have them there. Try to keep it on standby for any emergencies that we have to get somebody.
Excellent. Thank you. Well, I know we've gone over our time just a little bit, but if there is anything that you would like for all of us to be aware, most certainly you can email us, give us a call. As always, we're here if you need us. We want to say thank you for joining us either in person or virtually for this month's meeting. Next week is Thanksgiving. We want to wish everybody a happy Thanksgiving. Eat a lot, enjoy family time, and hopefully everyone have a wonderful time. And then historically in December, we take off for the month from LEPC because of parties and everything, all the hustle and bustle of the holiday season. But if that changes, we'll let you know. But as always, we're here if you need anything. So just give us a call. But we appreciate you guys. Thank you so much. Have a wonderful day.